We're going to talk about FlexSim and how you can simulate your production floor and plus plus. Let's put it plus plus. This is just an awareness webinar. I want to communicate the solution as much as I can. If you have questions, I'll be more than happy to answer them. If I don't know the answer, I'm going to go and get the answer. So we have all your email address. Simply put in the chat. If I'm able to answer them, I'll be more happy than to do so. I have 3 videos for each section. I have a short video and I have a demo video as well. So we're going to talk about it and we're going to see it. Basically, that's how it's going to roll this afternoon or this morning for some of you. So it is imperative for business leaders to keep an eye on industry trends. Executives at our customers wants to make better products, sell more of them, and improve profitability, but they need to identify their strengths and weakness and take the necessary steps to maximize their performance, especially as the manufacturing industry continues to face headwinds. In 2024, manufacturers continue to face economic uncertainty, coupled that with the ongoing shortage of skilled labor. Everyone is victim of that. Lingering supply chain disruption and the need to innovate to take on the competition while meet sustainability goals. So sustainability goals, right, but I think we need to find the right people for our jobs, and also we need to stay competitive and innovate if and when we have time. It's not as easy as it sounds. However, many of the companies who are looking to optimize their current factories or build new ones often face this level of chaos. They have broken processes, siloed information, and data scattered throughout the organization. So we see this all day, every day. Departments will work with pieces of data, and then when it's on to the next department, they're more happy to just send the data to the other department. If you pay attention, especially to when I'm talking or blogging, single source of truth, having one source of information is very important nowadays. And this little image is depicting exactly that. At GRAITEC, we help our customers to create anything from places to products. We have an expansive AEC and D&M portfolio to support our customers across many segments and industry. This allows us to help our customers design places, then make them, design the products, and make the products. This is our design and make advantage. Now, this line is very important. Data and processes management, single source of truth. Once again, we can support our customers across the full factory lifecycle due to the breadth of the Autodesk and our own portfolio. We also have solutions that we create, the GRAITEC specific solutions. This is how we look at the factory lifecycle today, and this is how we want to go to market across the 3 phases of design, build, and operate. Starting with design, we support our customers with the modeling of the building and the systems within it, the planning of the factory layout, and the simulation of the people and processes in the factory. We're going to talk about that today. In build, we support with construction management, coordination, and data management. We help our customers ensure their factory is built to spec by catching errors before they become problems and reduce potential downtime during operations. And in operate, we help our customers run their factory more effectively by managing production throughout the factory and automating the manufacturing process with our broad range of CAM solution. Together, GRAITEC and Autodesk Digital Factory Solution gives our customers the tool they need to get the most from their factory investment. Today, customers are on a journey to incrementally and continuously improve their capabilities that can make factory smarter. For customers to get started, they must build a common data environment, digitize workflows, connect systems together, which can help them unlock insights and areas to automate processes. So at each stage, we can help customers realize real tangible business benefits. To talk about these benefits, I will show you some of the great solution that FlexSim is. So our digital factories solution sits at the intersection of manufacturing and AEC to bring all the different functions together across design, build, and operate. We have solutions for all stages of the factory lifecycle, and this is all rooted within a common data environment. I keep repeating this, build, operate, design. It's true for many of you, if not most of you. All right, so let's intro FlexSim. And I want to make sure that I am giving you the audio from my share. So I might have to reshare if you don't mind.
No worries.
I'm doing it as we speak. Okay. Perfect. There you go. So I'll start a little clip, pretty short, just to give you a quick intro of what the solution is. And you should hear the video as well.
Would you like to accurately predict how your production system will perform in changing conditions? Maybe you'd like to test the design for a new factory layout, or validate a reconfiguration plan, or figure out the exact cause of that bottleneck on the assembly line. Spreadsheets can give some insights, but they often can't account for the complexity and dynamic nature of modern production systems. How can you get accurate analysis about future performance? FlexSim is easy-to-use 3D discrete event simulation software with high-end capability, allowing you to model any production process. It offers a data-driven, evidence-based method to predict how changes will impact factories, warehouses, and supply chains. A FlexSim simulation model allows you to validate and test what-if scenarios in a virtual environment without the risk of disrupting real-world operations. Your simulation model can provide a complete picture of the production environment. It combines detailed process steps, current production data, and realistic 3D visuals to tell a compelling factory story. Start meaningful new conversations and fully engage with stakeholders throughout your organization. FlexSim provides the capabilities you need to increase efficiency, reduce risk, and make better decisions as you make and move the products your customers are waiting for.
So it's super interesting. FlexSim is a great factory solution, and you'll see that it goes on top of factory. So I cannot wait to tell you a little bit more about it. So it's challenging and often impossible for spreadsheet and other analysis methods to consider these factors. Simulation does leading to more accurate analysis and better decision making. I mean, we've all seen it. We get a new machine, we get a new production line, and most of the time it's going to be very, very manual just to feed the machine. But there's ways to optimize that, or at least simulate what it would be if we use a forklift or another conveyor to get the raw material to the machine. Now, what is it? Factory design utility that we have in the product design and manufacturing collection. So factory is a simple solution that I love it because it brings 2D and 3D. Some companies will have a depth of knowledge from power users that were there when the company first started, or maybe they have something like 15, 20, or 30 years of experience within the company, and they are so capable in 2D, but a little bit shy in 3D. Factory or FDU is phenomenal for that, because someone that's a little bit more 2D prone will have a great time doing a layout of the factory. What's important with this solution is that you press a button and it's going to give you a 3D layout inside of Inventor. So the new kids, the cool cats that are a little bit more 3D inclined, will have a great time working with factory inside of Inventor. Now, what's interesting is that if you do some changes, some layout modification, you can also revert back to the layout. What's fun about this is that you can add your own machines, your own conveyor line, whatever you have that's personalized to you can be added to FDU. But this is very static. This is a picture of what your production will look like or looks like, and it is what it is. There's some simulation inside of FDU or factory design utility, but not so much. This is where FlexSim comes in. And this is where it gets very interesting. You can simulate your production line. Imagine that. I mean, not only can you see, or will you be able to see, feed and speeds and whatnot, but you can also see anything that would be, a problem for your colleagues, your coworkers, your employees. If a robot has a big wingspan, then you want to make sure that you protect that. There's no one that's going to, work around that area. So FlexSim is that kind of solution for that as well. All right, so FlexSim, when and why? Any process that you might have, and think about all the processes that you have. Now, I know I've talked about factory and production and products and whatnot, but also you can simulate, let's say, your call center. You could actually see a clear picture of how long a customer or client will wait on the line if they call your call center. You'll see. I have a little vignettes about this. For our own interest, manufacturing, assembly, material handling, people, this is what we want to simulate. And this is what FlexSim is so good about. We can prove new layouts, we can optimize existing production processes, and we can also, make accurate plans and also designs. That's very important. I once visited a customer that they were building boats. And they've been building boats for the last 50 years. And this is how they were building boats. So they had one boat, and crew workers or teams of specialties, whatever you want to call it, were moving from boat to boat instead of the other way around, where boats would move down a production line. And we just went and showed them factory and how maybe they could optimize. Even if they want to keep that process, then they might optimize a row of boats that are in the same stages. So employees, colleagues, coworkers don't have to walk that much. They can stay in those little cells of production and work on 2, 3, 4 different boats instead of walking around and trying to find the latest or where their project is. So it's just an idea. The challenges that FlexSim will solve are pretty simple. They're hard to simulate. They're hard to think about, but it's very simple. A production process is variable. Sometimes you have downtime, maintenance, machines, and whatnot. So it's not always running full-fledged. Sometimes there's stuff that we cannot oversee, we cannot think about, we cannot foresee. We need to be on the production floor and see what's happening. But most of this can be done in FlexSim. High costs. If your process is broken, of course, there's a lot of dollar signs attached to it. Just imagine if again, the example of raw material. Just imagine if you don't have a forklift that's available, someone, a team, 2 colleagues, 3 coworkers, whatever the number is, they will have to take the raw material and put it in the machine. But if you have a forklift, easy example, that forklift can take that raw material and just put it in a conveyor. The difference between paying 3, 4, 5 colleagues to do that same task when you could have a forklift doing it, that's costly. But you have to see it. You have to play with it to be able to foresee that. The long-term scenarios, most of the times we have a clear idea, not necessarily a clear view of where we want to be, what the outcome is. being able to use FlexSim as a simulation tool will give you a better idea. It's maybe not 100% precise, but it's going to be 99% there. And also risk in trying new things. Can you imagine stopping production lines so you can rearrange the workflow a little bit just for a test over the weekend? No, impossible. It's almost impossible. This is why you have conference room, wall to wall with those giant sticky notes and people writing stuff on them, trying to figure out the better way. But having a tool, 3D tool to simulate all this is just phenomenal over this. How accurately do you capture your system? So the value stream mapping, capacity analysis, KPI charts, flow charts, spreadsheets, this is all the tools that we use. But it's very manual, and also it's hard to be sharing this data. Most of the time it's going to be captured by us. It's going to be maybe in a small team of 2 or 3 people, but being able to do this manually is so hard. And sometimes, KPIs, just KPIs, an example. Sometimes a manager, an executive will ask you, give me some KPIs I need to share with the board or whatever. And you're going to share those KPIs, but where are they coming from? And how did you crunch those numbers? This is not super easy to share. This is why you want to have a tool that's going to give you all the data that you need, everything that you need, basically. This is some examples of customers. They're not necessarily a GRAITEC customer, but they're a FlexSim customer. Now, I should have maybe mentioned that before when we started the webinar, but FlexSim is an acquisition that Autodesk did recently. And so much so that FlexSim are still training customers and doing services with customers. But we're lucky. We're one of the few resellers or partners, I should say, that are certified to work with the FlexSim team and also offer it to our customers. So it's Carnes, material handling equipment supplier. We have multiple companies like that in our portfolio. So simulation models show that the number of pallets picked would rise from 70 to 100 pallets per hour, an increase of 43%. The 3D animation of the system also visually confirmed that conveyor congestion was greatly reduced, adding another level of validation for the client. Now, what's interesting about this, I mentioned executive, I mentioned manager, anyone that's maybe not hands and feet in production, being able to see in 3D what's going on is phenomenal. Think about it. Some of you may be like me. When I was studying mechanical engineering, I started drafting by hand on those drawing tables, and it was very hard to communicate the drawings that I was doing to someone that could not read plans or drawings. When we first started working in 3D, it was a lot easier. I mean, I could spin that 3D model and everyone around me, my friends, my wife, everyone would get it. It was easy. Same thing with this. Being able to simulate your production line and having someone that's absolutely not trained to get it will see it. That's phenomenal. And just that, it's intangible. You cannot put any value to this, but being able to get it quickly, phenomenal. I love this. This is something that unfortunately we cannot attach dollar signs to, but it makes so much sense. Several immediate outcomes of the model were a decision to increase the pooling of volumes across the Asia region, a decision to consolidate from 6 factories to 5, and an initiative to expand lower cost imports into higher cost regions for certain product families. So this is, the simulation they were able to see that maybe we could downsize a little bit and still be more productive. Imagine that. That's a crazy decision to make. If you don't have the data to back it, imagine going to the board and saying, yeah, we're going to shut down one of the factory, but we're going to be more productive. Show it to me, please. The goal was to create a working simulation model of the facility to use as a decision support tool. So they had a 3D model, but they wanted to see more. Since its custom interface has been set up to quickly change dozens of configuration and inputs, this model will continue to produce for months and even years to come. So because they have a model that's working, that's a replication of what they have physically, they can play with it. And I hate using the word or verb play because it's not necessarily a game. But, one case of insomnia, thought about something, come in the morning, plug in the numbers of the ideas you had, and you just see and go, and you don't have to disrupt anything. And if it works, perfect. Last second meeting, let me present to you the results that I got. And voila, super easy. All right. We're going to get into another video. It's going to be a little bit more in-depth, but not so much. I still want to talk about the solution before. We're going to end this presentation. We have plenty more time together. But the last video will be 7 minutes. This one is quite short, less than 2 minutes. But we'll get there, slowly but surely.
FlexSim is an object-oriented 3D simulation software that handles both discrete event and continuous simulation. It allows you to model any type of sequential flow or factory operation. If you manufacture products, build assemblies, or have warehouse or supply chain operations, FlexSim is the simulation product for you. FlexSim is used to eliminate waste in a production process, with waste being any action that doesn't add value to the customer. Waiting adds no value to the customer, and it's expensive to have excess waiting time for customers, products, and machines. FlexSim is a 3D simulation environment, so you can start with an AutoCAD file of the facility and drag out the resources for a true-to-scale model layout. The software also features a script-free logic building environment called Process Flow to help you describe even the most complex processes. This combination of drag-and-drop 3D technology and innovative logic building allows a user to model any system quickly and efficiently. Then bring your real-world data into FlexSim directly from Excel, a database, or an HTTP server using the latest available data to make accurate predictions about future production.
So the Connect the Flow example they had was a call center. So very interesting. I just wanted you to know, let's separate some things because I can hear your questions. I can read your minds. FDU, Factory Design Utility, is phenomenal to get an accurate footprint of our workflow, our processes. And also it's in one of our buildings, so it's in 3D and it's an asset that we can move around and interact with. What FlexSim is very simple. It's a simulation. So it's going to give you data, information of how you can increase your production or modify your production. It's not necessarily, everything is in 3D, yes, but it's not necessarily something that you can reuse an inventor in AutoCAD. So it gives you an idea. You can change your FDU models afterwards, but it's going to be simulating, optimizing your processes and workflows, but it's not necessarily going to change your inventor 3D and AutoCAD 2D models. Just to make sure. Okay. So the importance of DES. 3D representation of real-life systems, ability to each catch and eliminate mistakes in design, communicate design plans, evaluate ideas before implementation or investment, run what-if simulation, and identify the answer question about systems. So this is why we want to be able to simulate the workflow and the processes. So what can it solve? What can simulation, what can FlexSim solve? And this is the kind of questions that we will ask you. You're interested? You want to hear more about FlexSim? Perfect. We're going to ask you some questions. Are you wanting to compare different ideas or plans to determine which will be the most effective? Sometimes you don't even know about this. We've been doing this. We've been doing the boats for 50 years, and this is the way we've been building them. Perfect. It works. You're profitable. Hotcakes. Love it. What if we had a better way of doing those? What if you could sell more boats? What if it took you a little bit less time so you would have a buffer to adapt if, let's say, material not coming in and all that stuff? Kind of questions we'll ask. Do you have any bottlenecks in your systems? We all do. There's bottlenecks everywhere. Maintenance, raw material not there. Employees, we cannot fill the boots on the ground. There's not enough people that want to work in my production line. There's a lot of bottlenecks everywhere. Do you know what's causing them? Sometimes we don't. Is it a single thing, multiple factors? Sometimes we just don't know. It is like that. We react. We are not super proactive. We're more reactive to what's happening. But it's working. We have the right people, and we can pretty much react when it, and solve the problem. Are you thinking about expanding your current system? Are you thinking about having another line, adding a forklift instead of having manual labor? Just that. Before you invest, I don't know how much a forklift is, but it's expensive. I'm sure it's a nice luxury car. So before you invest that kind of money, would it make sense? Because a forklift, you have to acquire it, but there's more maintenance. They have to think about, there's fuel as well. Some are propane, some are diesel, some are electric. You have to think about that as well. Are you wanting to add automation to an existing system? That's interesting. Do you know do you have any new ideas that you wish you could test? That's something very important. And, is there any questions you want some answers? You got a new CEO, you got a new engineering executive, whatever the reason is, and that person goes, where I was working before, they had this and that, and it helped. It was very helpful in production. I wish I could show it to you. And sometimes you cannot necessarily visit the former plant or the other job, but having a tool to simulate it is very interesting. So how we can help? Test layout options, visualize flows, optimize and validate changes. It's quite simple. It is simple, and it makes sense for us because we are day to day in CAD systems. But for someone that's maybe was trained in CAD or not even, to come here and see something in 3D and see it, it's almost playing The Sims, but with real life projects and problems and solutions. For electronics, validate and optimize electronic manufacturing, understand staffing requirements, model rework and testing. Electronics is very, very interesting. And one thing I want to note, you see the floor is actually a 2D drawing. So you can import, you can import your 2D layout inside of FlexSim and just retrace on top of it with 3D models. But something interesting that I needed to say. Optimize warehousing. Now, of course, you see that warehousing, you're thinking, big bucks company, Amazon or something like this. But we all have, or most of our customers have warehouses where they stock parts in between processes, in between operations. They have that. So linked warehouse management system, WMS, to model actual data in order within a warehouse. Model complex material handling system. Visualize in 3D VR your warehouse. Process flow logic makes it easy to model complex operations. So something that's very interesting also to feel as if we were there. So VR is interesting. Ask my kids for gaming and chatting and whatnot. But VR makes sense when you want someone to get it. As an example, BRP. Those are building the ski-doos and sea-doos not far from where I live. They do trade shows, and when VR was just starting, they had one seat that could have been a ski-doo seat or a snowmobile seat, just a seat. And customer would sit on it. It's pretty much the same position, whether you're riding a snowmobile or a sea-doo. And they would put those VR goggles on them, and they would experience if they were riding a snowmobile or a jet ski or something like this. So it was just phenomenal. They got it. They had the experience. And sometimes having someone feel it, experience it, is phenomenal. Now you can move, because a warehouse is super big, and scrolling like this on a screen and trying to rotate and everything can take a long time. But having someone be, almost standing at a position in a warehouse and seeing around what's going on, VR is just a phenomenal solution for that as well. So model automated guided vehicle or self-guided vehicle. So maybe not in production nowadays to most of you, but those little robots that walk around, go get, fetch stuff and move boxes around and sometimes it can be as big as a forklift as well. So being able to optimize those movement is also very interesting. And robots. I'm not talking about robots here, but all those robots that are just swinging, and sometimes their radius of action is so big, and you need to be careful with this. And it could be a real hazard on the job site or in the factory. And people flows as well. So that's interesting. So sometimes we have factory floor, and someone at some point is going to mention, we should have a cafeteria here. No one was thinking about this. It's like, no, we're thinking about production. But if we're thinking about production, a new site, a new building, more employees, we need restrooms, we need cafeteria, we need parking spots. What is the flow like? How long will it take for someone that has like 45 minutes to have lunch to shut down the machine, make sure everything is safe and secured, walk to the cafeteria, maybe order a meal, get the lunchbox? You want to see that flow. And you can also simulate that. And this is interesting. And it's not just for airports or a shopping center and everything. It could be within your company as well. Super cool. All right. Now we're getting to the 7-minute demo video. And I'm sure you have questions now. You'll have questions after. We're almost done. I'm going to let a few minutes for questions. And again, no stupid questions. The only thing stupid here is my funny French Canadian accent. But ask your questions. If I don't know the answer, I'm going to go get it and email you back. All right. Sorry, I skipped this. So FlexSim, you'll see, and right now you see 2 videos. The intro videos were very short, but they gave you, it's intuitive. You'll see, it's drag and drop and connect. Is as simple as this. There's modules in there. You can have sections of 3D models available that you drag and drop. You don't have to scroll through conveyors, warehouse equipments and whatnot. It's standard object libraries and shareable user libraries. And you can also have your own database. So yes, you've guessed it. If you have a specific machine that's built just for you, I'm thinking sometimes the yogurt companies that have those filling machines that are very specific to what they do. Hershey, the chocolate bar maker, also they have their own machines. You can import that as well. And it's 3D. It's VR. It's just phenomenal. So it's intuitive, modular, and it's easy to get. The representation or representative box, what I meant was someone that's new to this will get it. And that's what's important. There's nothing worse than spending time on finding a solution getting the solution and having a hard time communicating the solution. When it's simple as watch this, press play and look, imagine that. All right, demo time. No, I'm not kidding.
There are 4 steps to build a model. The first step to building a model is to create a layout. It is helpful to import an AutoCAD or other layout file so we know where to place the resources as we build the model. To do this, select the Backgrounds icon from the toolbar, then select Add a Model Background. In the File Path field, select the DWG file you would like to import. The drawing can be sized to the grid using the options in the Model Background properties. With the drawing in place, drag a source, a queue, 3 processors, and a sink into the model grid. The second step is to define the flow of the flow items that represent our packaged products in the process. To do this, press and hold the A key on the keyboard, left-click on the source, and drag the mouse to the queue, and then release the mouse button. You should see a line connected from the source to the queue with an arrow from the source on the upper right side. The input arrow on the queue should be on the upper left side of the queue. Repeat the process to connect the queue to each of the 3 machines, and then from each machine to the sink. The third step is to detail the model. This means adding the correct process times and model logic to ensure the model behaves correctly. For this model, the only change we need to make is the process times for each of the 3 machines. We will try and balance this process the best we can. There is some variability in the arrival rate, so we will keep the default arrival rate of exponential 10 seconds, meaning on average, we will have a box arrive every 10 seconds. Since we have 3 machines, we'll try to maintain balance by giving each machine a processing time of 30 seconds. With the new model now complete, we move to step 4, where we run the simulation and evaluate the model. In order to evaluate the model, we'll need some kind of performance indicator to gain information about how the model is performing. Since the objective of the model is to look at the utilization of the machines and the wait time of the boxes in the queue, we need to add a couple of charts to the dashboard so we can see what's going on. To do this, select the Dashboards option from the toolbar and then select Add Blank Dashboard. This will dock a blank dashboard panel to the right of the layout view. If you click on the panel, the library on the left will change to a selection of chart templates that you can drag into the dashboard panel. There are 2 charts we want to add to the dashboard to help us understand what is happening when we run the model. The first is a state chart. Add the chart by clicking and dragging the state chart from the library to the dashboard panel, and then click on the chart. You'll see the properties of the state chart in the Properties panel. Select the picker icon in the Objects field, and then select each processor in the model so that each one shows up in the field. The second chart is a stay time chart, so click and drag the stay time chart from the library into the dashboard panel just below the state chart. Click on the chart and then use the picker to add the queue to the chart. The last thing to do is set the time that the model will run for. For this model, 8 hours should be sufficient to see its behavior. Select the down arrow just to the right of the runtime field on the toolbar. Down at the bottom of the pop-up window, check the stop times box, then set the stop time to 4 p.m. Hit reset, then run to watch the model run. You can adjust the run speed control to speed up the model to run the 8 hours in a matter of seconds. Now that the model has run for 8 hours of simulated time, we can look at the results of the run. Wait-in time of the queue is 278 seconds. Average processor utilization is 98.5%. This means that on average, parts are sitting in the queue around 90% of the time. This bottleneck is caused by the high utilization of the processors, which is over 98%. To relieve the bottleneck, we must lower the utilization of the processors. As you can see on the utilization versus wait time chart, if the utilization of the processor could be lowered to 92 or 93%, the wait time in the queue would decrease significantly. One of the main benefits of simulation is that it allows the user to quickly test what-if scenarios and better understand the system. To lower the utilization of the processors, there are 3 options available to us: reduce the arrival rate, add another machine, or speed up the processing time. We can assume that the arrival rate is the pace at which customer orders arrive, so we don't want to slow that down. We can also assume the purchasing of another machine is an expensive option that could be avoided. It's decided that the least costly option for us is to use training and automation to speed up the process. The goal is to lower the utilization of the processors by roughly 10%. To do this, we would need to reduce the process time by 10%, or a 3-second reduction in the processing time at each machine. Changing the process time is simple. Just click on the processor, go to the Properties panel on the right, find the processing time field, and change it from 30 seconds to 27 seconds. Do this for each machine, then rerun the model. Now that the model has run for 8 hours, we can look at the results of the run. Wait time in the queue, 54 seconds. Average processor utilization, 90.5%. Looking at the utilization versus wait time chart, you can see the average wait in the queue has dropped significantly to just 54 seconds, and the utilization has dropped below 91% on average. The bottleneck is cleared, and only a small number of packaged products remain in the queue. Over the course of time, this represents huge savings by eliminating waste and improving throughput. This is the essence of process optimization and the improvements you can find by using FlexSim to simulate and optimize your processes.
I love that example because the solution is quite simple. We have orders, we have boxes, and it was mentioned super quickly, but training. If we can cut down by 10%, which is 3 seconds, the amount of time that someone will handle that box to the next process, I mean, we see how much speed we gain. And it was just about training, better training. As simple as that. All right, so key takeaways before we go to the Q&A. FlexSim allows people to build 3D representation of real-world system. Point blank. I mean, we can go from our manufacturing processes all the way to, all right, it's lunchtime. How much time would it take for people to sit in the cafeteria? FlexSim considers the effect of variability, interactions between model elements, and time on a system. And FlexSim models can be used to test out solutions to problems, gain insight into a system, test new ideas, and compare ideas to find the best solution. Quite simple. Now, thank you so much for joining this webinar, but it's my time to try to answer your questions. Okay, I think we had some, right?
Yes, sorry, I was muted. We have one from Chris first. Could this application be utilized in minerals, material handling, and processing, in parentheses, mining?
Oh, that's a great question. I know that they have a customer that's a mining company. I don't know how to use it. So, Chris, if you allow me, I will get the answer and send you an email. I want to make sure that I'm not saying anything stupid or more stupid. So I'll get the info to you. And I'm taking notes right as we speak.
Perfect. And yes, we do have some frequently asked questions about FlexSim. One of those was, how does FlexSim fit in with digital twin solutions?
All right. Oh, that's a great question. So digital twin, there's multiple layers for digital twins. Sometimes it's to get a as built, especially in the construction industry. They will have a 3D model of a building, a house, whatever. And then they want to have a as built to see the slope change or anything like this. So they're going to get a digital twin of the real building. Nowadays, digital twin also gives us a pulse. It's almost like a living model. You can see if your elevator is stuck. You can see if a light bulb is burned, needs to be changed. You can see if a door is locked. There's a lot of stuff like this, and this is mostly digital twin. FDU, so Factory Design Utility, is a tool to help you with the digital twin. And it's mostly if you bought a process line, if you bought a manufacturing line or a company, sometimes you want to have a 3D model, a 3D representation of that new facility. So that could be considered digital twin. But if you were thinking IoT, Internet of Things, that gives you a pulse or something that's happening, this is not necessarily a digital twin tool. You can use it to mimic what's in real life, but it's not going to breathe if a machine is down for maintenance. It's not going to tell you if a line is stopped because of something is broken, anything like this. So it's not a real 2024 digital twin, but it can get you there. Thank you.
Awesome. And from Andrew, we have another question in the general chat. Can you confirm the import formats available for model importing?
So model importing will have to be tweaked into graphic models. Andrew, I'll send you the information. I know it's graphic, so we need to remove all the CAD aspect of it because it's just graphical. I'll let you know more, but it needs to be lightweight. That's what I'm trying to say. Yes. And then if you want to have movement, you need to build that animation as well. So it's what they have in the library is very interesting because everything is built, animation is built. But if you want to create your own models, it needs to be tweaked a little bit. So it's just a shell of your machine. And if you want some animation, you need to build this animation. With that said, they have tools that's included with it that allows you to do that. But I'll get back to you, Andrew, with the models.
Great. And then we have another one. I'm a freelance simulation engineer. I would like to know what other Autodesk software you would recommend I learn to use to get even more out of my FlexSim skills. Great question.
That's a great question. Factory Design Utility, I think, is the best way to start. Because as we've seen, the floor was actually a 2D layout. So we were using the 2D layout that was built in AutoCAD using FDU, Factory Design Utility. And then the person just used the library of FlexSim and added conveyors and whatnot on top of it. So Factory Design Utility is a tool that's included in the Product Design and Manufacturing collection. And if you know your way around AutoCAD and Inventor, you're all set. It's a matter of drag and dropping your blocks or models or equipment, and then you get a 2D layout and a 3D layout as well.
Perfect. And it looks like we have one final question. What is the competitive advantage over using the FlexSim software compared to Arena or AnyLogic?
I don't know a lot about those two, but since I don't know enough, let me do some research. I'll ask the FlexSim people, and I'll get back to you. I don't want to say anything that's wrong.
That'll be in part 2 of this webinar, right?
It could be a part 2. That's very interesting. But I'll get back, Andrew. I'll get back to you. I will get back to Chris, and sir, I'll get back to you regarding Arena and AnyLogic, just to make sure.
Well, perfect. That looks like all the questions we had. Would you like to discuss any of the other frequently asked questions, like who on my team would be using FlexSim, just in the general sense?
Anyone that, so most of the times we have an optimization engineer or a process engineer. Those two might be interested in FlexSim, but not only them. If you have someone that's involved in production or that's a little bit more leaning towards production, I think they could use FlexSim. Absolutely, with ideas, with discussions. Also, people on the floor, your production engineer, people that are running those machines, or maybe the managers of people running those machines that have ideas, that have experience, that know that, they turn around 15 times per day to get materials. Maybe there's something that can be done. Anyone that has an idea can communicate that to the process and optimization engineers. But mostly anyone that's a little bit CAD oriented could absolutely use it.